Yes, Okay, thanks for the question. Hopefully you can hear me. So the difference between shallow basements in clay material and shallow basements in sandy material. The latter is not suitable for deep well dewatering. However, I think deep well dewatering is suitable to moderate to high permeability soil from the lecture. Yeah, so I'll answer this one first, then I'll get to the ENR one. We can use deep well dewatering for essentially any material as such. It's really subject to depth. So if we've got a shallower basement with sand, then PVC spears is definitely the go-to, or vacuum dewatering system is going to be the best system. It's going to be able to evacuate the water a lot faster. faster, and it's really quick to install. It's also just more appropriate. So if we've got a clay material though, it's frequently better to use a deep well system because it takes some time for that clay to dewater. So the ENR formula is not really examinable. You need to probably understand the concept of using the formula. So why would we use the formula? Well, a pile driving analyzer would be obviously used to help us estimate the capacity of a driven pile. So hopefully, but you won't need to actually apply that formula in the exam, so you shouldn't have to worry about that too much. I'm just checking the last part of this question. Thus is the reason for choice that hyper. Yeah, so I mean, both dewatering systems, if you're in sand with a high water table, are not going to be economic. It doesn't sort of matter if we do deep well dewatering or PVC sphere dewatering. It's simply not going to be an economic solution unless we create a water type barrier around the basement. So maybe we'll do a bit of a sketch here. So maybe if you've got a basement like this, and we have some cut-off walls, and maybe we want to excavate down to here, and potentially we have some sort of sandy material here. Now we would want to construct these basement walls first. We want to construct these walls first. Then we can potentially dewater out of the site, so long as this material down here is sufficiently impermeable. Otherwise, you're quite right that if we're just dewatering in sand and we've got a high water table, the costs could be really significant. So, it's not necessarily a matter of economy so much as appropriateness for the situation. Okay, so I'm going to go on to Young's question. So how would we consider a partially reinforced pile? A pile where the cage does not reach all the way to the bottom. That's correct, yes. Or a pile that has less leakages and fewer main bars. So no, a partially reinforced pile is just not reinforced all the way to the bottom. So it might be 5 metres down or 10 metres down or something like that. So not necessarily all the way to the bottom. And that would be done if we were not expecting tension to develop all the way to the base of the pile. But we'd reinforce the top to handle either tension or bending moments in the pile as well. You just came... That just came for the Jack Russell. Okay, I'll show you the Jack Russell then, and then I'll get to the other question. Come here. Okay. There we go, there's the Jack Russell. It's sleepy though, aren't you? Good dog. Okay. Alright, so we've got a number of questions here. 2016 mock exam. There's quite a few there. Thanks, Harry. I don't think you're that likely to fail, Faz. It's from looking at the marks, especially task 4. I don't think very many people are going to fail this subject, if any. So we'll see. So I'm going to just do Marvel's question first. There's more questions coming in than... Okay. So I'm going to do question A10 of 2016. Here's what the depot. I think the choice was Shelley. Yes, I agree with you, Marvel. Yes, I think it is the least appropriate for deep well dewatering. So I'd agree with that post. So I'll go to LZ's questions now for the 2016 mock paper. So let's bring this up. Okay. Exam materials, 2016 mock exam. Great. And you are after questions A2. So A2, when excavating bank or in situ material, which is likely to expand the most when excavated? Okay, so rock's going to expand the most. We didn't really cover that as much this year, but yeah, rock, because it doesn't stack really very evenly, it's got lots of voids, that will expand the most out of those materials. So A15, in an earthworks project, I'm not going to explicitly answer this, but in fact, this question, to be completely honest with you, was really confusing. And when I sat down with some students recently to go through it, we couldn't really figure it out because it's a bit more complex than it first appears. So I wouldn't worry too much about this. If you can do the equivalent earthworks questions on the other examinations, 2006, we're in the wrong year, I think, 2016 or the like, I wouldn't worry too much about that. It should be fine. It's 2015. Anyway, okay, so A18, which of the following is least likely method for crossing the Yarra River with road tunnel? So this should be pretty clear cut. There are tunnels under the Yarra that are being bored, the Metro Tunnel for example. Caisson construction is essentially what was done with combination of cut and cover for the Burnley Tunnel. I don't really this question's hard too, which is probably why it's on a mock exam. But an immersed tube tunnel is just not appropriate because we wouldn't be able to float the sections down to Yarra. It'd be too large to float down a shallow waterway. So both C and E are really not appropriate methods in this example. So I don't know, probably C, but it's not a great question. I hope we don't have any quite like that on the exam where there's two correct answers in my opinion. So don't worry about that too much. That should be okay. Cool. So we're moving down now to Fraser. Yep, great. When multiple boom lengths are appropriate for the mass and radius, what justifications are there for selecting one boom length over another? Typically, if you haven't got height requirements, so if you're not lifting high up on a structure, you keep your boom shorter. You pick your shorter boom length that'll do to lift. Takes less time to extend, and typically you'll have more capacity from your crane as well. Just pick the one with usually the maximum lift capacity. That would be sufficient justification. So Marvel, you've now asked about 2015 mock exam A2 for expanding. Oh yeah, rock or clay. Yes, we've done this one. Yep, great. It's definitely rock in this instance. So 2016 exam B2E, recommend a bridge construction method and deck support system for a bridge that is to have 3 240-metre spans with towers above the deck. So this is based actually on Jeff Taplin's lecture, and it's essentially an arch bridge or a box girder arch bridge, and that's because we can't go to cable stay because we can't have the towers above the bridge deck. So my recommendations, have a bit of a look through Jeff Taplin's lecture. It's a bridge up in Brisbane, and he talks a little bit about that one, so worthwhile checking. Okay, so for the next question, 2016, question 19, I think. For the safety factor of 2.5 to 3, should we choose the longest one length? When you say the longest, there should be only one answer within the range of 2.5 to 3 factor of safety. If there's not, I would double check your calculations. I see. So Harry, you're asking about construction method. Okay, so as soon as we're doing an arch, we can't really incrementally launch it. It's not appropriate. So coming back to your previous question, we'd have to use a balanced cantilever construction method for the arch, or a more innovative method like Jeff talked about on one of the bridges in Sydney, where they sort of constructed a temporary arch. So maybe I can have a bit of a sketch of it here. Let's see. Okay, so On one of these waterways they constructed a temporary arch like this made out of steel. Okay, and then they slid sections of the girder over this rail system and post-tensioned them together to create an arch. But usually, if we're going a variable depth bridge, we'd use a balanced cantilever. So start at a central pier and begin working your way on either side. You can either do this with precast segments or cast in situ. If you use cast in situ, you will get a longer span bridge than a precast, because the precast elements simply get too large if we're getting too big spans. As you'll see on Jeff Taplin's lecture, he talks about when the spans get too long, it doesn't talk about it, just shows the table, I should say. But when the spans get larger, we have to go to cast in place box girders. Okay, great. So we're up to the tanked basement question. So is tanked basement the only choice for Coot Island silt? It's a pretty good question. No, I think it's probably the short answer. If we had a nice impermeable material beneath the Coot Island silt, we could create a cut-off wall. So let's sketch up a layer. Here's our surface. Maybe we've got some sandstone here, and let's call it Coot Island silt here. If we're going to construct a basement, we could extend our cut-off walls, maybe a secant pile wall, maybe a D wall, into the sandstone, and then de-water out here and construct, and have a hybrid basement. And we get away with a hybrid basement in this instance because we know our flow net looks a bit like this. Okay, it has to flow through this sandstone, and if our sandstone is really rather impermeable, then we would find that we get actually really low flow. So you could get away with a hybrid basement. That's one example, getting away with a hybrid basement for Coot Island silt, if you could create a cut-off wall into the sandstone. Otherwise, if your basement's solely in the Coot Island silt and we have a high water table, then yeah, we would probably have to go to a tanked basement. Cool. So we're going to look at question 2016. 2016 A19. Okay, let's have a look. A19. Oh, okay. We've been asked a few of these. Maybe I should go through one calculation on it then. Okay, let's have a look. I haven't done this one in a while, so we'll see how we go. But we've got what grouted length should we choose for an anchor of a grouted diameter 120 mil? D is 120 millimeters. Okay. And sorry, I'll flip that back up. And it's at 20 degrees. 20 degrees. And we got SU equal to 110 kPa, and the force is equal to 200 kilonewtons. We need a factor of safety between 2.5 and 3. So I'd probably start this with a factor of safety equal to 3 and just pick a length that's just less than that. But anyway, let's have a look here. So we've got the force in the anchor required is going to be 200 divided by cos of 20, because it obviously has to apply more force at this inclination here. And we know that's equal to pi times diameter, 0.12, times length, so pi dl gives the surface area, doesn't it, times SU, which is our adhesion, so that's 110 kilopascals. And what I can do now is I can solve for my length, and then I can multiply it by either 2.5 or 3. So length will equal 200 divided by cos 20 times pi times 0.12 times 110. Okay, so, I don't know, let's check it, see what we get. So, cos 20, I might have to do this on my phone, sorry, that calculator's not that good. Okay, so I'm just going to put this in the phone, you can check it as well if you need to. Cos 20 times pi times 0.12 times 110. Okay, so I get a length equal to 5.13 meters. So I need a factor of safety between 2.5 and 3, so times 2.5. Okay, so times 2.5 is 12.83. I think made any mistakes. Not yet, hopefully. 5.13 times 3. 15.4 meters. Okay, so what does that mean? It means, looking at our answers here, looking at our answers here, we're in a little bit of trouble, aren't we? Because none of these quite line up. I've either made a mistake or not. I actually can't remember. But if this was the case in the exam, I'd choose 18 meters because it's going to give us a slightly larger factor of safety, which is safe. So yeah, I would choose 18 meters in this instance. Yeah, I don't know. Double check the calculations there. If I'm right, then yeah, just round up to the nearest answer. Okay, so there's a lot. Will this be available later? Yes, I'm recording this as well, so I'll upload it after so you can watch through. Although I don't think it's going to be a particularly interesting watch, but anyway, why would you select one length? Okay. So 2016 exam, question A9, what is the function of a bulldozer? From my understanding, it can be used for excavating. Yep, I guess so, yeah. It is for pushing the soil to become stockpile. Yeah. Okay, let's bring it up then. So 2016, that's this one, A9. What is the most significant function of a bulldozer? Excavating most materials, excluding rock and transporting short distances. Sounds pretty reasonable. Excavating soft or loose material and transporting it up to 2k. Too far for a bulldozer. Finishing an earthworks project, not really. Trimming battered slopes, not really. Scraping and compacting, not really. So yes, it is A. So pushing the soil to become a stockpile is excavating the material. Yeah. Yeah. But you're right. So is the answer C? Were we looking at the same question? Not really. No, so the answer is A. So yeah, you're right, it is pushing material, but it excavates that material as it pushes it. So 2017, oh, I'm gonna have to, okay, give me a moment to open this one up. Exam 2017. Oops. Fine, 2017. Okay, so you're after 2017 A22. Which method would you recommend to calculate the design capacity of CVA pile? So we talked about this in the consult yesterday. I think it was yesterday. And you would use a CPT test because CPT is far more accurate than an SPT test. We haven't yet installed a pile, so we can't do the testing yet. And if it's in a remote area, getting a lab to test the material is going to take a long time, and it's not necessarily going to be any more accurate than our CPT test. So it's definitely CPT. Have a watch of Gary Chapman's lecture for more info on that. It's pretty interesting. So is dynamic load testing. So dynamic load testing, it's going to take less time than a static load test, but we have to install the pile first. So if we're doing some preliminary calculations, it's not really appropriate. If we just want a quick answer, then SPT or CPT are both appropriate, but SPT is far more approximate than a CPT. That's Kevin's question. So we're up to Lawrence now. I feel, how can we improve pile capacity without changing design or risk factors? And the answer is pretty much in Kevin's post, which is testing. So we can improve our capacity, calculated capacity that is, through testing. The more we test, the more confident we are in their capacity, and hence the greater the Phi-G-B factor is, and hence the greater calculated capacity. So 2015 mock exam question B5. K is given, which range of K is considered low and moderate, hence determining type of basement. Choose a hybrid. Okay, let's have a look. So 2015. I think the mock exam was the same 2015, 2016, so I think this is the same one. I hope so. So we're up to B5 here. B5. What range of K is considered low and moderate? Okay, yeah, it's probably a pretty good question. So -7 is probably, that's quite a high permeability for a clay, actually. -7 is probably a moderate permeability. -5's moderate to higher permeability, I would say. So probably you can do a bit of a search here. So permeability of common materials, common soils, I should say. Okay, so here we go. So wow, that's a terrible reference. I thought we actually had it in the workshop there, but anyway, that's okay. We can have a bit of a look here. So gravel -4, so that's really high permeability. And maybe we go clay sand, a range of -6 to -8. -6 to -9 for a clay sand. Once we get to a compacted clay, we're kind of -9, which is quite impermeable. So yeah, geotechdata.info, that gives you a bit of a feel for it based on materials you're familiar with, I guess. But I don't know if I've answered your question. We choose hybrid for and hybrid for B. I think you're right there, but let's go back to the exam. Would you change if instead of clay, coarse silt? Yeah, you'd stick with a hybrid if you could key in your basement wall into the impermeable basalt, yes. If you couldn't key in your basement wall into the impermeable basalt, then yeah, you probably need to go a tanked basement. But I think you're on track with that, so that's fine. Okay, so Christopher, for 2016 mock exam B5. Do we select hybrid for A and tank for B? Could you confirm? Let's have a look. 2016 B5A. No, I'm on the wrong paper. 2016 mock exam. Sorry. This one. Okay, so provide recommendations on whether you do tank drained hybrid. Okay, so I think I've semi-answered this a moment ago. Stiff clay to 20 meters. The clay is underlain by high strength impermeable basalt. Okay, so you're saying a hybrid for A. Well, look, with this permeability, I think a hybrid is a fairly reasonable recommendation. If this was, say, 10 to the -8 or 10 to the -9, I think you'd probably be headed to drained because you've got such low permeability. And if it was, say, anything less than this, then we would want tanked unless we could say we're keying in our basement wall into the impermeable basalt. And that's the same response here. So the marks we gave in these were dependent on what justifications you gave and whether you talked about keying in your wall into the impermeable basalt or not. Yep, your answers are fine, but you would have to state to get full marks for both of them that you're assuming that the basement wall's not keyed into the basalt. Okay, cool. So, hi, I'm wondering what type of basement is in 2017 B5. Okay, 2017 B5. New basement that consists of one car park level below the ground. Good Island Silt 0 to 15, Fisherman's Bend built 15 to 20, water table's high, basement 1 level car park. Tank drained or hybrid. Look, you could probably get away with a hybrid basement here. But if you said you were really concerned about settlement to adjacent properties, then you could also recommend it tanked, but you couldn't recommend it drained. So it would really depend on your justification here. A wall type, the only mark we probably would have given here is the secant pile wall, and the construction steps I think everyone's pretty good with. So again, it depends on exactly your justification, but yeah, I think a tanked is probably quite appropriate, as is a hybrid, if you said you were particularly worried about settlement. Okay, I'm wondering what B6F in the mock exam. Clients asked you if you would recommend using soil no walls to help support the basement wall. No, you would never do that. You wouldn't do that because they're not tensioned. Because they're not tensioned, the basement wall would have to move prior to activating or stressing the nails, and we wouldn't end up with a vertical wall. Not only that, they don't usually have anywhere near the capacity of our ground anchors, so they're just not appropriate for this application. Okay. What's the difference between the serviceability capacity and increasing the limit state capacity for board piles and CFA piles? The difference is, look at, I think what you probably should do is look at the formulas that are used to calculate the capacities and the variables that are going into those formulas. For example, Thi-G is used in limit state, but it's not used in serviceability. Additionally, the end bearing capacity is used for limit state, but it's not used for serviceability. So that will give you a feeling for what factors are feeding into it, and then you need to look at what affects those factors. I know it's a bit of a general answer, but I hope it makes sense. So next up, we've got, I just want to ask the A17 in 2017, which should I choose? The more specific you make the questions, probably the better I can answer them, but that's okay, we'll work. A17. Okay. When the water table is much lower than the basement floor, when would you choose a tank basement? The answer is never. Well, there's no point in choosing a tank basement if our water table's far below the basement floor, because there's no need. It's going to cost us money, and it's just not necessary. Okay, whoa, hang on, it's just updated. Wow, there's a lot of questions. How can I donate? Oh man. Why do many tunnels in Melbourne use cut and cover? They use cut and cover to begin because two reasons. One, if we're using, say, a tunnel boring machine, we need to get it at some depth in order to start boring. So maybe I can do a quick sketch again for you. This wasn't really covered this year that much, so don't stress too much. But for your interest's sake. So let's say we want to build a tunnel, and this is the profile for the tunnel maybe. Okay, we cannot start the tunnel boring machine here because there's nothing above it. We have to start it at approximately 1 tunnel diameter, 1 to 2 tunnel diameters beneath the surface. For that reason, we actually have to excavate all this material here. So we could leave this is the bottom of the tunnel here, I guess. We could leave the top of this open, but obviously in the city, this land's really valuable. So we want to reinstate it after building the tunnel. So cut and cover means we cut out all this material, we drop in our tunnel boring machine or the like, and then we cover over it later on to reinstate the original land use or another land use as such. A22 2017, when should we choose a SPT static and dynamic load test? What would you recommend? I did talk about this earlier. I'll let you download this video later on and have a listen. I think it was about 4 or 5 minutes in I talked about this one. So, exam 2017, question A21. Oh good, we're in the right spot. EPB TBM can be used for option A, B and C just depending on the length of the tunnel. But C is used immersed tube, so C is the valid option. Use A, B and C and just depending on the length of the tunnel, C is used immersed to C. Well, I still a valid option. You're kind of right. C is, I mean, this example here, you're right, they did use an immersed tube tunnel. But you could use an EPB TBM. And this year in the exam, which was last year, I actually gave answers for D and E were both marked as correct. Because yeah, you could use an EPB TBM for a lengthy tunnel, lengthy waterway crossing as well. So you don't have to worry too much about that. How can you donate if you cannot? I'm getting paid, so you don't have to worry about that. So 2016 mock A3. 2016 mock A3. Yep. Geological materials unlikely to be found in Melbourne. Oh, you'll be testing me on this. Granite is, I think, at least, yeah. Granite's not that common around Melbourne. I think you have to go a fair bit north to get any granite. So that's the answer there. Looked at GMAC, but found all 5. Well, there you go. Okay, so this question, Jim gave a lecture this year for the subject, and he talked about these different materials. So it's really based on that lecture. I believe you found all 5, but I was under the impression we can bring up the map. Map Melbourne. Okay, yeah, this one will be fine. No, that's too big actually. Let's go this one. Right, so look here. So we got, you don't really have much granite here, really. I think you have to go further north of Melbourne to get particularly much granite. Anyway, that's okay. I think we're getting a little bit distracted here. Good. So, and the question, when we can use scraper to transfer soil. So scrapers are really good to transfer soil sort of short to mid-range distances. When I say short to mid-range, I mean 100 metres to a few kilometres would probably be the best application for a scraper. They move it very quick, a lot of material those distances, much faster than a bulldozer, much faster than a loader. When the distance gets less than 100 metres, you're probably better off using your bulldozer and forgetting the scraper. when your distance gets further than, say, a few kilometres, you're probably better off using a truck of some description. Okay, so A13 for 2016, let's have a look. A13 for 2016, that's the mock, 2016. Which is not a design issue for hybrid basement. This one should be easy, because there's no buoyancy on a hybrid basement. The floor's not sealed, so there is no buoyancy. So that's the answer there. Make sure you're really 100% clear on the differences between a tank, a drain, and a hybrid basement. Have a look back at Nick's lectures; they're quite good there. So 2016, 2017, sorry, A6. Do we still need a loader as an excavator's used? Good question, and no, we don't really need a loader if an excavator's used, do we? Because the excavator can load directly in the truck. So, in what case should we use a highway truck or highway truck? Also a good question. So, usually off-highway trucks are used exactly that, off-highway. So in mining applications or big earthworks projects that are in relatively remote areas. Anywhere where you're going on the highway, most of the time you would just select a highway truck. There are exceptions to that, and special permits can be granted to use off-highway trucks on the highway from big roads, but in any urban application you will not see off-highway trucks. So, I mean, when was the last time you saw a mining truck on the highway? It just doesn't really happen. So, as soon as you're driving on a highway, you're using a highway truck. If you're out in the middle of nowhere working on a mine site or a quarry or a big excavation of some description, then why not? Off-highway truck's going to have much greater output. Cool, so 2017 B3D, is it necessary to consider a barge in the middle of the river, or is just a coffee dam enough? Actually, no, let's have a look. B3, where have I put this paper? Here it is. Okay, B3D. I mean, you could do a cofferdam, but I think you probably should have a barge in this instance, because you're going to have to cofferdam off so much of the river to put in a pile. A barge is definitely the correct answer here. We did focus a lot more on waterway crossings this year as well, so it's probably less pertinent for 2018. Okay, so according to lecture size in week 7, bulldozer can be used for trimming and battering a slope. It can. Page 32. Yep, okay, so no, I stand somewhat corrected. You're right, the bulldozer can definitely be used for trimming and battering a slope. I don't know, I don't know if I'd call it its primary function, but it's definitely something a bulldozer can do. Yep, no worries. So 2015 mock exam B6E. Will increasing water level means increasing inflow significantly? Okay, I think we need to bring up the question. 2015 B6E. If the groundwater was to increase to 3 metres, how would this affect your wall type recommendation? What we've got is a fine sand over a stiff clay. The water table's 11 metres down. We want to build 3 levels of basement to depth of 9 metres, which is still above the water table, isn't it? So yeah, it almost certainly will affect your wall type recommendation. So if your groundwater table's higher, then we can't have a soldier pile wall, because we're going to get too much inflow into our let me finish reading the question. The contractors offered 2 alternate designs. One used a second pile wall into the stiff clay, and the other using a contiguous pile wall. So you should really have been recommending a contiguous pile wall because you're above the water table, but you have a loose sandy material. And then, when the water table rises, you should be recommending a secant pile wall to exclude that water from the basement. And a hybrid basement would be fine because you create your cut-off wall in the stiff clay. Hopefully that makes sense. I don't know if I need to sketch it. Yeah, so it will increase the inflow significantly. Yeah, I agree. Yep. Okay, so A11 on 2017, as for the Coot Island silt, how do we deal with it when we want to dewater? A11 2017. Yeah, so we talked about this quite a lot yesterday, or whatever it was. So this is the answer. It's the answer so D is the answer. The answer because we principally, not from timing, but from location of dewatering. We don't want to dewater around our site for Coot Island silt because we're going to cause settlement to adjacent properties. We do need to consider it when we're excavating, so it is D is the correct answer here. Okay. Can you show me the calculation for 2017 A8? Should it be 9? Let's have a look. A8. I think it was 9 from memory. It should have been a pretty, not too complex a calculation. I'm going to have a really quick look here. I probably won't finish the physical calculator side of it because there's lots of questions, but I'll do the, I'll write out the formula. So we need to do 20,000 cubic meters of in situ material, and we have a loose to in situ ratio of 1.2, so I'm going to multiply that by 1.2. And I want to know how many dump trucks I need. I know their factored capacity is 260 cubic meters per hour, so I can just divide that by 260, and this gives me hours for one dump truck. Let's have a quick look. So 20,000 times 1.2 divided by 260, 92 hours, 0.3. We need to do it in 12, so I just divide that by 12, and I get 7.69. 7.69. I rounded up to 8. This is A8 for anyone that's tuning in, I guess, of 2017. I think, but let's double check it. So 20,000 cubic meters of in situ material. I'll times that by 1.2 to get loose because I know I have a in situ, a loose to in situ volume ratio of 1.2. So that means my compact in situ ratio is not used, is it? Because I don't have any compact volume, so I don't have to worry about that. I don't have to worry about my excavators because that's not what the question's asking. So I think it's 8, but if I made some stupid mistake, then yeah. Anyway, okay. 2015 mock exam B7E, is it just referring to 3 risks considered: site design, construction, control? Let's have a look. 2015 B7E. This is a good question. I mean, if you just said that, Marvel, I don't think I'd probably mark you as correct because that's not really saying what the benefit is. The benefit is it's encouraging designers to use more robust methods. It's encouraging testing, which gives you a surety of the pile's capacity. It also takes into consideration on-site risks, construction risks, geology risks, calculation risks to give a a more encompassed risk assessment in terms of your capacity calculation. So you really got to look at what is the benefit of using these standards, and it's all those things. Gary talked about it a little bit in his lecture, but yeah, it is these risks, but they're being considered and they're being factored in rather than just using a factor of safety. Yeah. Okay, Kevin. 2016 B3G and H. B3G and H. Is the answer install soil now and Aga? Algorithm got it. Okay. Loose good iron silt, sandy material. Mention two things that could be done to keep the pile from collapsing during boring. So this during boring means as we're constructing the pile, how are we going to stop it from collapsing? The answer is definitely not soil now and anchor. Because the question's asking about constructing the physical pile itself. So we could do one of two things. We could either fill the pile borehole with bentonite slurry, or we could use a steel casing. So they're going to prevent the pile hole from collapsing as we're boring. Dewatering for H. Let's have a look. H. The team leader mentioned other projects in the region have had difficulty with excessive sediment. Detail two things that can be done during construction to minimise pile displacement under load. So you need to clean the socket. Well, that'll help. You could roughen the socket. That would help as well. So they're two such examples of things you could do to minimise displacement of the pile under load. So no, deep watering is not going to really is not critical here. Okay. So for CFA construction in the middle of a river, should we use a cofferdam to prevent water contamination? You should do something, for sure. A cofferdam is one answer, yes. Another answer is a steel tube and CFA within that steel tube. Both are correct. So Pi, 2017 B4H, dynamic testing order formula. Let's have a look. We're going to end up doing every exam here, I think. P4H. An alternative solution precast. Hang on, is this the right one? P4H. Oh, briefly describe an economical method of assessing the pile during construction. So, precast pile, you're hammering into the ground. Dynamic testing order formula, it's one and the same thing. So you would use, the answer we were after is using a pile driving analyzer to calculate the capacity of the precast pile. So that in effect is dynamic testing, and it uses, say, the ENR formula, but you needed to say pile driving analyzer to assess the capacity of the pile is what we were after there. 2017 B2C, recommend an economical construction method and deck support system. Okay, we talked about this a bit yesterday too. So this is a steel composite box girder bridge. That's the best one. We could just crane it into position. That's the most economical in Melbourne for these longer spans. If it was much shorter, you'd probably choose a Super T. If it's much longer, you'd probably go a concrete box girder. 2016. So construction method, yeah. So you would crane the box girder into position and then cast the deck on top, just to make sure I'm answering the question properly. 2016 A4 and A12. This is it. A4. Yeah, this is it. A4. So this rating of a crane refers to typical, maximum, this one here, see, maximum lift rating in tonnes. A12, when doing MCA, significance and an impact. So the more significant an impact is, the more weighting it deserves. So the weighting scale of the impact being measured, that would be a correct answer. If we're talking about something really significant, then it deserves a high weighting. We're not talking about exactly if the impact's positive or negative, we're just talking about significance. So it's not the score, it's the weight. The scoring scale set before any of this. Client preferences should have nothing to do with it. Number of people. Well, look, I mean, it could influence the number of people that should be performing the assessment, maybe, but it's not the most correct answer. It's definitely the weighting is the most correct answer. Well, wow, okay. Alright. We'll do the best we can here. There's a lot of questions. 2017 A1, 60, yes. Incremental launching, no. So it's too far to incrementally launch. You've got too many spans. Yes, so a barge, yep. Lifting temporary piles takes lots of time. Yeah, but if you're in real deep water, you can get really big, heavy barges that are capable of huge lifts. You can lift the entire span in one lift and actually do it rather quickly. There's an example up in Canada. I think Jeff talked about it at the end of his lecture. Check that for me. So 2016 exam A16, the option D stated diaphragm wall cannot form an effective water seal due to panel joints. Can we take this as true? No, it's not true though, because we will put in hydrotite between the panel joints, and that would make it form an effective watertight seal. So hopefully that answers the question. So for B5 in 2015, should we consider different settlement between clay and silt? Would the silt settlement generally? Let's bring up the question. 2015. I mean, settlement wasn't the main point here in this one. No, I don't think. I don't know if I 100% understand. Can you explain a little bit about what flighting is? Yeah, cool. Yep, I can definitely do that. I don't know if it's talked about much or at all this year, actually. But yeah. So, let's say we're going to install a CFA pile, and maybe we've got two layers here. A moderately weathered basalt here, and maybe a sand here, some description. We're going to punch in our CFA. So our CFA rig has our giant corkscrew, as we well know. We're going to put that in the ground. It's going in and in and in and in until it hits this basalt. Now, we're trying to push this corkscrew in. However, once we hit this hard basalt, it's going to be very difficult for it to penetrate further into the basalt. Because of that, it's actually going to start lifting out the sand faster than it's going into the ground. And you might say, well, why does that matter? It matters because we're going to start drawing the sand in to this pile rig and flighting around the pile, which is obviously not a good thing. So the key point with the CFA is it has to screw in without bringing up any material until we start pumping the concrete in. Then we can bring up the auger as the concrete fills the hole. But we don't want the material being brought up before we put the concrete in, because it kind of defeats the purpose of the CFA. So flighting is where we hit a hard material, we can't get in we can't push it in, and consequently we start pulling the material out and collapsing around the hole. Yeah, hopefully that answers. I don't think it was a great explanation, but. So, 2015 Mock B4, name 3 construction engineering risks and their mitigation measures for an urban road tunnel project. I think, well, look, Gordon, we probably haven't talked heaps about road tunnel construction in an urban setting this year. It's more a question for last year. I guess my answer to you is be sure you can do that for the topics we covered well this year, not last year. Yeah. So, for the A17, which exam I wonder is, if we not choose the tank, how should we deal with storming? It's hard to deep water. Yeah, Coodle and Silt is hard to deep water. Look, sometimes it just gets wet and we just have to deal with it. I mean, Delta Group has been working with Coot Island silt down in South Melbourne, and what they do is if they get a big pile of wet Coot Island silt and they can't dewater it in time, which is frequently the case, is they'll excavate it out and they'll spread it out on the ground and let it dry a little bit on the ground before putting it in the trucks to take off site. So it's a problem, but it's not something that's not able to be handled. I don't think that probably answers the question on the exam though. I'm not 100% sure which exam you're referring to, so let me see. Yeah, I'm not certain. Maybe post it again later on. I'll hopefully get to it. Marvel, more questions. So 2016 exam PT3D. We calculate serviceability load. It's higher than Part C. Yes. Does it mean that serviceability is now capped to ultimate limit? Yes, that's exactly what it means. You're correct. Yes, and we talked about that a fair bit yesterday. Yep, that's spot on. So, Jan, what's the relation between shaft resistance and pile diameter for rock-socketed piles? The relationship is, as we increase our pile diameter, our total force from the shaft will increase, but the stress on the shaft will decrease. So Gary talked a little bit about this, although not in great detail, but so the smaller the pile, the greater the stress on the outside of the shaft, and the bigger pile, the less that stress. But the area of that shaft increases faster than stress decreases. So we're always going to get more force from a bigger pile, as you would expect, but the stress is lower. Maybe it's worth bringing up Gary's notes here because that's not that easy to explain. This one. Here it is. It's a... Okay. Sorry, I can't really... I can't show it because it's PDF. No, I can't. So what it's got is a plot of shaft resistance versus diameter of the pile, and it was found that a larger diameter resulted in less shaft resistance. That being said, look at your units, it's in kilopascals, so that's a stress. So that's stress multiplied by the area, bigger piles, more force, but less stress. Yeah. Not a great explanation, I'm sorry, but what is the difference between air flush and water flush? Well, air flush is using air to blast out the debris that's being drilled, and water is using water. Air flush generally doesn't disturb the anchor hole as much as water, so we usually get a larger bond stress. Water also creates a big mess of like wet, watery, slurry mud when we're drilling our anchor hole. So air flush is probably the most common method in Melbourne. Air flush will also handle really higher strength stuff than water flush methods. Yeah. So Arthur, when determining serviceability limit state load for a group of rock-socketed piles, if the factored structural capacity is less than the unfactored shaft resistance, are we supposed to use N piles times RDS for serviceability limit state? Yes is the short answer, but I would write this as a literal sentence in an exam. I would write serviceability limit state equals maybe, 15 meganewtons. However, the structural limit state was only 9 meganewtons, therefore serviceability load should be limited to no more than 9 meganewtons. That would be a perfect answer in that respect. But yeah, you're right. So Jan, 2017 exam B5B, why do you... Yeah, okay, so, yep, I've answered this earlier on in the webinar, so I'll post this video for everyone a little bit later. So, go back. Kevin, 2016 Mock A4, is the maximum grade for the tram the same as the train? No, I think it goes steeper. I think it's 2% for a tram. We won't assess you on that because we didn't really talk about trams this year, but yeah, I think it's 2% for a tram, steeper than the train. So, Bresson, 2017 exam A15, in terms of civil wall, Are we talking about soil nail or sheet pile wall here? Yeah, it probably should be a bit more specific. You're quite right, but we're talking about a soil nail wall here. Yeah, we're talking about a soil nail wall. So soil nail wall is typically cheaper than a. Actually, no. Maybe I should bring up the question. Is this the question? 2017 A15. Sorry. A civil wall. So we're talking about. Let's sketch it here. So we're talking about a slope. This is our civil wall. Maybe we've got a road down here, and we're going to nail it. Maybe mesh it and shotcrete it. That's a civil wall. Versus a vertical earth retaining wall that, with ground anchors back. This is obviously cheaper. It's cheaper because, so this is civil wall, yeah, and this is just a retaining wall, a vertical one. Here we have to pile for our retaining wall. Piling, we know, is fairly expensive. We got ground anchors, they're fairly expensive. Our civil wall, we've only got shotcrete and soil nails, so cheaper. This is following on to the next question, which is good. What's the difference between a civil wall and a soldier pile wall? Well, yeah, so this one could be a soldier pile wall. Soldier pile wall. We know what a soldier pile is, looking from above, we've got piles, panels, whatever. Civil wall is just a sloped excavation in this instance. Okay, so what's the maximum length of precast pile and beam used in Melbourne? Length. I think we can order a precast pile up to like 18 metres of length, but it'd probably be pretty rare we do it that long. Usually 12 metres would be our limit. But we can keep joining them together and hammering them in. So there's no real, there will be a practical limit, but there's no technical limit on how long your precast pile can be installed, because we can keep adding more and more piles on top of each other as we go in. I'm not certain about what you mean by the beam, but yeah, the precast pile lengths can be really quite long. So 2015 B7E D walls in second wall is not great waterproof at great depth. Probably. It should be B6E 2015. Let's have a look. I don't know. B6. Wall type recommendation. No, I think you can get away with a secant pile wall here. But I don't think you probably would have recommended a secant pile wall before. You should have probably only recommended a contiguous pile wall, I think, because your water table was high. Well, it wasn't that high at first, so you probably started with a contiguous pile and then went to a secant pile, I think is what we're after here. I think. Post again if that doesn't make sense. So, Fraser, 2017 B3C, ensuring sufficient support capacity of the barge for a crane in the Yarra. Okay, let's check it. Okay, yeah, so you wouldn't know the answer to this, Fraser, because we didn't really cover it this year. But for your own interest, what we would do to ensure we had sufficient capacity for our barge, this is in plan view. Here is our barge, and it has jack-up piles on the corners. What we would do is we would ensure we had the capacity of the barge on only 2 piles. Okay, or half the number of piles. So we drive in half the piles. If we had the capacity with half the piles, then we know when we put in the other piles, we've got double the capacity. So that's how it's done. They just put in half the piles and then the other half, and they've got sort of a factor of safety of 2, I guess you could say. A10 2015 mock, why did deep quality watering cannot be used for sanding material? I got this heaps. This probably wasn't a very good question. You can use deep welded watering for sandy material. It's just a PVC spear method is better. Is the exam a hurdle? No, Joe. The exam's not a hurdle. Don't stress. Why is silt damp? I don't know. I don't know. Silt's probably frequently damp because the size between the gap between soil particles is small, so like clay, it's got capillary action and can stay damp. But I'm not sure I understand the question. Anyway. Oh man. Okay. Yes, that's correct. Yep, you're right, Faz. Rock's going to be more. Marvel. Mock A2 was answered, and the answer was E. Rock. Oh, good. Thanks. Thanks, Marvel. Bresson. Would you explain this? Boom 25 capacity 140. Would you explain this? B3B. All of it? I don't know. Let's have a look. We're right on it. I guess that helps. Yeah. Okay, let's have a look. So 20 ton, 42 meters. What's our boom length? So we go 42 meters, read it across to here. I picked a shorter boom length, 48 meters, gives us 20.5 tons. That's the first answer. Next up, you need to also lift precast columns 8 tons, raised 58 meters. So we go 58 meters here. 8 tons, we can lift it with any of these boom lengths. But none of these boom lengths will have our capacity of 20 tons. See, we have 19, 18.5, 17.8, and 17.3. So none of them can do it for our 20 ton lift. So I would recommend a boom length of 66 meters for our second lift. And I think we covered the rest. So use yeah, the counterweight's 140 tons. That's correct. I don't know exactly what. Anyway, I hope that answers it, Bresson. I hope so. Would elevating the crane by 35 meters increase the crane radius and hence increase the boom? I don't know. I think you're misinterpreting this last one. I wouldn't worry too much about jacking up the barge. So, G. Hugh, what are the difference between a box girder span by span and box girder balanced cantilever? Span by span, I'm not actually all that sure what a box girder span by span is specifically referring to be completely honest. I was under the impression it means whole span being lifted into place. So maybe we'll do a bit of a sketch here. I would also call this whole span precast potentially. So first up, balanced cantilever. We have our central pier and we construct on either side and we work our way out, balanced cantilever. Until obviously we reach the other side and we do the same on the other side until we meet up in the middle. Balanced cantilever. Great. So whole span precast, if we've got a pier here and a pier here, we just lift in the entire section with the crane in one lift. So that's span by span. We lift in a whole span. So that's obviously heaps faster, but we've got huge weights to lift, and we also have to transport this thing to site, which isn't that easy. All right, cool. Could you summarise the main properties of Coot Island silt? Yeah, relatively low permeability, very reactive material. Its permeability horizontally is greater than that vertically because it's built up in layers. and it's got quite a lot of organic material in it. So you've got a little bits of seashell and all sorts of stuff. So low permeability, very weak material as well. So weak and reactive. Sorry for the previous post. It's on question 17 on 2017. The issue is concerned is for see if the reactive soil is good on silt. How should we consider dewatering system? Using pump out and recharge. Yeah, pump out and recharge sounds great. Yeah, why not? And it's yeah. I think the option was C, wasn't it? We can check that maybe. If react. Okay, so this one's none of the above. I think this is the question you're asking. Okay, we're up to now Bresson's post. How do we increase socket roughness? So we do that by putting a tooth on the outside of the borer. So just a protrusion of steel, and that will sort of cut a spiral into the socket, which will roughen it. Why sometimes we have teeth at the end of drilling rig? End of drilling rig. So I'm not certain I understand the question, but we have teeth to help cut rock, typically, or just to I guess have more cutting power. But if we've got a sideways tooth, then that helps to add to roughness. Yeah. Okay, 12. Sorry, it jumps around. 2015 mock exam B6E, is D-wall acceptable? Since second pile wall is not greater wall at the depth. I think I've asked this. Oh no, I haven't answered this. So I think you can handle. You could get away with a secant pile wall here. I think it's not too deep. I wasn't under the impression. I don't think. Let's check it. Sorry, I can't remember how deep the basement was. Oh, I've lost it. (2016) B6E. How deep's our car park? It is 3 levels. No, we can get away with the secant pile wall for 3 levels. It's okay. That's okay. How deep can the ring possum cage be placed in the CFA pile, Joe? Well, sort of 20 to 25 metres is usually the considered practical limit. When would a peer-reviewed assignment marks be released, Joe? Well, we don't really explicitly release the peer-reviewed assignment marks. It gets conglomerated into your final mark for the subject. So I guess the answer is they're released with the subject result. So let's start a question again. Since referring to W2 lecture content, they use D-wall for 2-level basement when there is sandy soil there. Yeah, you're right, they did too. I remember now. They did too. Well, yeah, so I guess it would be based on the client too, and how important it is to have a really waterproof seal. So if it's just a car park, it might not matter that much that they get a little bit of water leaking in. If it's maybe something of higher value, a lecture theatre, a cinema, then maybe they say, right, we don't want any water in there, for a D-wall be appropriate. So you're right. You could recommend a D-wall, but you'd have to put a proviso of depending on the client preferences. Okay, so Arthur, in the construction sequence for Kudal and silt during the dewatering stage, is it correct to state that there will need to be constant monitoring in neighbouring areas to track settlement and reduce damage? Yeah, I think that's a good answer. Yes. What's the dog? So the dog's name is Lumi. Yeah, it's Lumi. Okay. Can you give me a shout out? Joel, yes, I guess so. Fraser, when calculating the structural capacity of piles, when do we assume partial reinforcement? Wow. For CFA, when the bottom can't be reinforced, yeah, that's a good example. Yeah, for sure. If we've got a CFA pile that's 35 metres deep, then we're going to have to pretty much assume it's partially reinforced. We're not going to get reinforcement to the bottom. But really, it's not something you just generally would assume. It would come back to the structural engineer a little bit, which I guess is probably you. So yeah, it's based on what's required from the pile. If you've got a lot of tension in the pile and it's rock socketed, you would have to do it fully reinforced. That's for sure. So Jonathan, question A2 2016. Let's have a look. When excavating, rock is the answer here. Rock's the answer. Yeah. So, that's mock. Is that the right one? Sorry, no, I think I'm on the wrong one, aren't I? Sorry. A2 2016. Least representative casting place board piles. Okay. Costly. Yes, they're costly. Unable to place reinforcement. Well, we are able to place reinforcement past 30 metres, so that's the answer. Good. Bresson. Sorry, Phil. It was 2016. When evaluating the crane by 30 metres, increase crane resistance. Okay, we have to look at this one. Yeah, sorry, that makes more sense now, Bresson. Alright, 2016 mock B3. Otherwise, I did not understand what was going on. Alright. Still in the wrong paper. 2016 mock B3. 700 ton DMAG. We're going to do 50 tons, 18 metres horizontally. So let's look 18 metres. We can use any of these booms. Great. Easy. What distance should the boom be extended? Well, we can do any, but I would recommend 20.5 metres because it's got the shortest boom length, it gives us greatest capacity. Mentioned run requirement to perform the lift. Outriggers, fully extended, 140 tonne counterweight, correct. Now assume the same lift at a distance of 18 metres needs to be performed at an elevation of 35 metres. What is likely to happen in boom extension recommendation? So, if you recommended 20.5 metres, you must extend your boom longer, because if we're going to have to lift 35 metres high, we're going to have a much longer boom length in order to reach that height. So the answer is increase. Yeah, hopefully that helps. So, Joe, is the primary issue with driven piling in Melbourne a noise to install? Yeah, I'd say so. And heave in South Melbourne, if we've got lots of piles, heavy loads, heave can be an issue too. What's the issue with precast bridge elements? Wow. I mean, we have to transport them there and we have to lift them into place. They're the main issues. How many types of deck supporting systems we got? Oh man, that's a big question. Sangzi? I don't know if I can. I think probably watch Jeff Taplin's lecture. I'm not really going to assess you on anything Jeff didn't cover. And it's a really good lecture too, so watch through Jeff's lecture. If there's something specific there you're like, I don't understand this system, I'm happy to talk about it. Kurathana, 2016 B1B, let's have a look. 2016 B1B, yeah, so this is a weird one, isn't it? Probably not going to ask you this question, but that's okay. Let's have a look at this. So if we've got, we'll just zoom up on a section of the bridge. If we've got the deck there and we have cables coming down like this, then the deck is either one of two things. It's either simply supported or continuous. If it's simply supported, our bending moment diagram is just going to look like this between the cables. If it is continuous, let's draw another one maybe. If it's continuous, then our bending moment diagram is going to be negative at the cables and positive in between, like this. Both answers this year got full marks. But yeah, I guess the point of this question was to understand that it's these cables that are providing the support to the bridge. It's not the actual piers of the bridge, it's the cables. That's what needs to be understood. Diaphragm wall, can it be keyed into rock? Yes. Can we expect accept more testing, which additional method can be used to increase 5G? I think you need to go to the Australian standards and check what's factoring into the 5G. Why can we place reinforcement deeper in board piles than CFA? Joe, this question concerns me a little bit because it shows that you don't necessarily get the difference between a CFA and a board pile. A board pile, we're ending up with an open hole in the ground, so we can just drop the Rio in as deep as we need to. The CFA pile, we're ending up with a hole in the ground full of concrete, so we just can't force the reinforcement cage into that concrete very deep. I think we're getting to the end here. Exam 2016, question A16. Answer should be B or D. Let's check. 2016, B. No, sorry, A16. I think this is 2016. It is. Which does not apply to a diaphragm wall. It can be keyed into rock, so it's B, I think, but let's check D as well. They cannot form an effective seal. They can form an effective seal if we put hydrotide in these joints. Okay, so hydrotide, Nick brought the sample in, it'll swell up in a joint and it'll seal the water. So we can form an effective watertight seal, yes. Also, is only hard pile or second pile can be keyed in? No, we can key in the soft pile. The soft pile is only soft because of what we're filling the pile with. If we fill it with a soft, weak concrete, no reinforcement, it's a soft pile. We can still construct it via boring into the rock. So no, we can get both piles softened into the rock. We might go a bit deep with the hard pile to get more capacity, but technically you could socket both in. How deep can... Yeah, so this question I would have essentially indirectly answered a minute ago, but how deep can steel Rio cage go in a board pile? As deep as you can drill the hole, because you can just keep lowering it in. So there's no literal limit on a board pile reinforcement. So the Eureka Tower has fully reinforced board rock socketed piles down to a depth of 55 metres, for example. So Xiao, exam 2017 A10, which one is the best choice? 2017 A10. Let's check for you. Five-story basement. Okay, the best one, stop work, backfill the basement, because this thing's unstable. So the number one priority as an engineer is to make sure it's going to be safe. Okay, so if we backfill it, we're putting soil back in the basement. We're making sure it's not going to collapse. Anything else there's either not going to solve the problem or it's going to put more people in danger, except I guess calling you a lawyer, but they're not going to know how to solve an engineering problem. So yeah, C is the answer here. That I believe is the best choice. 2017 B2C. 3 spans, 45 metres. So plate gird is pretty good, but the best solution here is... Actually, let me double check this question before I get too far ahead. B2B. Sorry. So the best solution here is a composite steel box section. Jeff talked about them a bit in his lecture, but we've got a steel box section that's cast with a... I can bring it up actually. Hang on. Lectures, Jeff. Where was he? Here. Okay, so we're just looking for the steel box section thing. Lots of great slides here. Good lecture. Here, so box girder, composite steel and concrete. So these are the most common for these sort of a bit longer spans, a bit longer than Super T's. New Chandler Highway Bridge Upgrade is using these. You can see all these shear studs along here that are going to cast in with the concrete. So that's our composite action. Here's some more. They're just lifted in place with the crane and the deck's cast on top. Beautiful. Okay. Is there going to be any question related to level crossing removal? Oh, maybe. I don't know. Joe, Mock exam 2015 A12. Do we need a bulldozer? Let's see. 15. No. Sand's already stockpiled, so you don't need a bulldozer because it's already in stockpile. The bulldozer could put it in a stockpile for you, but because it's already stockpiled, no, we do not need a bulldozer. Message retracted. So 2016 exam B4 with reinforcement percentage 1, we still use partially reinforced equation. Don't know. Let's see. 2016 B4. The client has requested your advice. Is this the one? I don't know if I'm on the right exam. No, sorry, Ziyang. Post that again. I can't quite see which one you mean. Okay, so Andy, 2017 B1A. Let's have a look. B1A. Nearby residents are annoyed about noise and dust. What are you going to do about it? Well, noise barriers for noise. This is actually a really good question because the last 3 nights in a row, there's been roadworks out the front of this where I live, and they're putting up noise barriers. And they don't seem to be doing a whole heap. Apparently 3 decibels of attenuation, but it's not much, not enough to sleep. Anyway, yeah, so noise barriers for noise, adjusting your working hours potentially, building a shed over the tunnel border wall so helped with noise and dust, ensuring that you've got a water truck on site, you're hosing off any dry soil to reduce dust. That's all relevant answers there. Yeah, so there's a range of things, noise and dust. I'm trying to think of some others. Yeah, they're the main ones. 2017 B1A. That's one good. Cool YouTube live concept. Yeah, thanks. I didn't want to go into uni, so I thought I'd do the YouTube live. It seems to be working well, and it saved everyone else from going to uni too, I guess. Thanks, Marvel. I think A and B are both right. 2017 A2, you're probably right. Let's have a look. So you think A and B are both right. Extremely difficult to construct from budge. I don't know. It's difficult. Cast in place board piles. It's not extremely difficult though. I guess yeah, it's a bit open to interpretation. But this year we covered this a lot more. It's not that hard. If you insert a steel tube, you can construct your pile within that steel tube. It's not that big a deal. So A's less correct. Yeah, we're looking at the right one. 2017, I think A and B are both right. Mine right exam, yes. So B's not right. Most representative. Yeah, so B allowed. Yeah, that's correct. So no, I think A's less. I think B's the correct answer. Is what I'm trying to say. Sorry, I think B's the correct answer. In 2016, A5 is still box used because of longer span requirement. From memory, yes, I think that's exactly the answer. Yes. What is the construction method in 2017 B2B? Balanced cantilever or incremental launch? Let's check it out. B2B. Oh, hang on, sorry, I'm on the wrong. No. B2C, sorry. Recommend an economical construction method and deck support system for a freeway overpass in Melbourne. So I actually think neither. I think if you're using one of those steel composite box girder bridges, you can just crane in the steel box girder and then cast your slab on top. So it's sort of whole span craneage, I guess would be the answer there. Xiang, maybe it's 2017 B4. Yeah, there was something weird going on a minute ago. 2017 B4. Let's check for you. Oh, I don't know. I think you have to be more specific. CFA pile. Oh yeah, now I remember. CFA pile deep, 36 meters with reinforcement rate 1%. Yeah. Okay. Yes, you're using partially reinforced equation because you cannot get the steel reinforcement below the sort of 25 meters tops. So for that reason, we'd have to use partially reinforced. That's why the question was stated in the way that it said your colleague has stated that standard reinforcement rates of 0.5 to 1% are common. So I didn't say we're using this reinforcement throughout, and that's why you're using partially reinforced. That was a tricky question that year for sure. Yeah, cool. Wow, I think we've made it through the questions. Nobody else has got anything else to cover? Can't think if there's anything else I should address. We've covered probably almost most of the questions in most of the exams now. What I'll do, if you tuned in a bit late or missed some of the earlier questions, I'll come to that question in a moment. If you tune in a little bit late, I'll upload this whole video for everyone to watch later on. When we used unreinforced question, yeah, look, it's pretty rare you've got an unreinforced pile. So I would say Hongzheng, it's just a very unlikely scenario that we'd use an unreinforced pile in most all instances. So thanks, Blue Kingfisher. I hope it's been helpful. Do we have a conservatively assumed? Look, I think most bored piles, if you're boring a pile, you're going to fully reinforce it. You need a lot more capacity, so bored pile, fully reinforced, unless stated otherwise. Thanks for the session, Norris B. I hope it's been helpful. Andy, so at what percentage will be considered as a fully reinforced pile? It's not so much a percentage as the reinforcement itself does not extend to the base of the pile. If that's the case, it's partially reinforced pile. Look, at the end of the day, if you've got a bored pile in this exam, assume it's fully reinforced. If you've got a CFA pile beyond 25 meters depth, assume it's partially reinforced unless told otherwise. That's sort of where I'd go from. Good. Okay, thanks everyone. I think you've asked a lot of really good questions there. And yeah, I think we got through it all. So good luck. I will see you all tomorrow. I'll drop my exam. Hopefully everyone does well. So yeah, good luck, and yeah, I think I'll sign off now. It's been a reasonable session, so thank you. And I'll upload this in case you missed some of the earlier stuff.